Now we'll discuss a regression example where the independent variable, x here, is something other than the time period. That is, it is some other variable that could help predict the dependent variable, that is the sales. You might want to pause this video now and read the problem in the text box here. As you have read, the 10 restaurants here are all near some college campuses, that is, different college campuses. That seems like a good business strategy. A college campus represents a large customer base in a concentrated geographical area. And what college student does not like pizza? Cheap and tasty and fast, and students certainly have limited budget and time. Now, we would expect a restaurant located near a campus with large population to make more money since they have larger customer base. We could see that in the scatter chart right here. As you could see, as the population grows, sales also increases. We want to define a regression relationship between the quarterly sales and the student population. That is, sales is equal to some intercept plus some slope times the student population. That is, y will be equal to the quarterly sales and x will be equal to student population. Y is what we want to predict and x is the factor that will help us predict it. Using this regression relationship, we could make a forecast for the new restaurant location near campus of 16,000 students by plugging in the appropriate x value in the equation. Now, we could use the same formulas for intercept and the slope as before. It's same thing as before. Intercept, y values first, comma, the x values, and close parentheses. Same thing here as before. Slope, y values first, comma, and then the student population values. So there it is. Intercept is 60 and the slope is 5. So here we would plug in y is equal to 60 plus 5 times x, and that's the regression equation. Now, if student population is 16,000, since x is in thousands of students, we would plug in 16 for the x value. So here we multiply 5 by 16 and then add 60. That gives us 140. Again, in terms of dollar amount, it will be $140,000. Let's write that right here. So we did problem A, or part A. If we wanted to use the Excel formula, then we would just stick 16 in here for the population, and sales would be calculated by the entering the usual formula, intercept plus slope times the population of 16. As you know, we could get the same regression equation by working with a scatter chart. We could insert a trend line equation into this scatter plot. As before, we select one of the data points, right click, add trend line, and then display equation chart. And that's it, is right there. That's the same equation. 60 is the intercept and 5 is the slope. So we could see that population of 16, it might be about right here, and that would mean somewhere over here on the line, which should correspond to about 140,000 that we have. Now let's take a look at part B. What is the marginal quarterly sales generated by one student? So that is, what is the value of one student to this restaurant in terms of quarterly sales? Now, how much does this restaurant make from one student in a quarter, that is in 3 months? We could answer this by looking at the slope. We know that the slope here represents increase in y from 1 unit increase in x. Now, since y is in thousands of dollars and x is in thousands of students, then we could say when student population is increased by 1,000, that translates to $5,000 increase in quarterly sales. So then what is the value of one student? Well, it must be $5. So let's write that down. So 1,000 more students, that translates to $5,000 increase in revenue. So one more student would mean $5 more. So here the answer is $5 per student. This means $5 is the average amount of money a student will spend at this restaurant in a quarter, in 3 months. Well, you might say, well, that is a rather small amount. But keep in mind that the average value 5 here would include the students who never go to this restaurant. So if you ask all the students how much money they spent at this restaurant last 3 months, some of them would say, oh, well, I never go to the pizza place. I like Pizza Hut better. For such students, you would record 0 for the amount, and these would be counted in the average calculation. Now that we've discussed the role of the slope, let's talk about the intercept. What does the intercept represent in terms of quarterly sales? So the question is, what do you think this 60 represents? Now, if this were the cost formula, you would say that, well, 60 might be the fixed cost and 5x might be the variable cost. But this is revenue, not cost. So is 60 a fixed revenue? Well, it's the part of the revenue that's not affected by the value of x, that is the number of students. The sales these restaurants generate from students is 5 times x. Well, then what is 60? It must be sales made to the people other than the students. The students are not the only people who would go get pizza. There'll be other people, like people who work or live in the area. So we could interpret a 60 as the amount of sales from non-students. So the conclusion is that these restaurants make sales of $60,000 per quarter from non-students. So here we could say $60,000 from non-students would be how we would interpret the intercept. What we did in this example is a simple regression that we had only one x variable, that was the student population. And of course, there are other factors that might influence or help us predict the sales. For instance, maybe in the amount spent on advertising, then we would have something like this. A third term with the x2 in it. So we have b sub 0 plus b1 x1 plus b2 x2, where the x2 might be the advertising expenditure. Then what we'd have is a multiple regression. But in this class, we'll limit the discussion to the simple regression.